9, 1-800.
We live in an age where the chance of...
Sounds incredibly complex. It sounds like students, you need to have abilities that span. I'm really geeking out here. Probably most of our college students know a little bit about thermodynamics, but high school students and others, can you just say a little bit what you mean by thermodynamics?
Yeah,
and
sure.
And you just described a whole bunch of different places where thermodynamics comes in. And so how does it relate to toilets or mixing or the project that you're working on?
Definitely. So what my lab focuses on, right, is looking at the interconversion of heat to other sources of energy, right? The tagline is, we focus on direct thermal energy conversion technologies and thermal transport technologies. And what does that exactly mean, right? Fundamentally, I think people are aware that we have flows of energy in the world around us. One of the most common flows of energy is heat, right? We kind of classify heat by the common modes of heat transfer that we encounter. We have conduction, which is the transfer of heat in solids. We have convection, which is the transfer of heat between a solid and a fluid or between fluids. And we have radiation, the transfer of heat through light, right? And that kind of forms a fundamental scientific base, which we can then apply to different technologies. And what I'm always interested in is how can we convert heat to another form of energy? And that conversion is largely described as thermodynamics. How do we take heat, thermal energy, and convert it to something else? And so that's kind of the underlying thrust for my lab, is how do we better utilize heat, right? Sometimes we use it to generate electricity. Sometimes we use it to generate mechanical motion. Sometimes we use it to generate chemical species, right? We can also run all those in reverse. So I can use electricity and I can provide cooling technologies like air conditioning, right? I can take even nuclear energy, right? Beta particles, and I can convert that to electricity. So it's just really the interconversion of all of these different energy forms that kind of encompasses what my lab does. Because heat is such a large component of our energy sources, we focus a lot on how can we transfer and move heat and use it most effectively. And then the utility of heat in a very efficient manner, that's also an underlying principle for thermodynamics. Mm-hmm. The approaches we're taking once we have these separated streams in a toilet is our goal, our specification is to really obviate fecal-oral pathways, right? Mm-hmm. And the challenge within feces is bacteria and viruses, right? So when I look at that, my job is to really arrest bacteria and viruses. And so one way of doing that is heating everything up, right? So if we can elevate the temperature of that waste stream for a sufficient duration, that largely ends up killing most of the pathogens, right? So that's one of the first approaches that we want to do within this toilet. The problem there is, even if I kill everything, right, I still have a very nutrient-rich stream, and there's enough naturally occurring bacteria in the air that if I just discharge that nutrient-rich stream, a lot of these bacteria will come back.
I see.
So we're concerned about regrowth.
Even just regular old contact with the any other environment that has bacteria in it.
That's right. So if I have this pasteurized waste and I just leave it exposed to air, things will start growing again, mm-hmm. right? And so that doesn't solve the ultimate goal of obviating fecal-oral pathways. So we have to take it one step further. And what we have to do is take that sanitized waste and we have to make it devoid of energy, right? We have to remove all of that energy. And that's where we'll look at other chemical and physical means to do that. So once we, for example, let's say we were going to combust it. Once we take it to a form of ash, things won't spontaneously regrow because we've removed all the energy from the system, right? So we have to look at how we remove that, but what do we do with it? It'd be a shame just to waste it, right? And so a lot of the concepts are how can we take that energy and actually utilize it?
cold is only the absence of heat, and heat doesn't just disappear. It has to be carried away